The moon orbits the Earth over a period of 29.5 days. While the moon orbits, the light from the sun hits the moon at different areas and reflects to the Earth, causing it to look like the moon is changing. We call this the phases of the moon. There are many phases of the moon, but we are just going to go over some of them. The new moon is the first moon of the lunar month, and it is when the Earth, moon, and sun line up in a straight line with the moon in the middle, so the sun shines on the back of the moon, but we do not see that. The waxing crescent to the first quarter is when the moon moves to the left of the new moon line, so you can see a crescent of the moon that eventually becomes a quarter. The first quarter is when the moon is on the left. A waxing gibbous is the stage after the first quarter, but before the full moon. The full moon is when the moon is behind the Earth, and the sun, Earth, and moon are lined up once again, but now the Earth is between the sun and the moon, whose front is lit up for us to see. Then the moon continues moving, creating the last quarter. The last quarter turns into a waning crescent before returning to a new moon. Why does the moon orbit the Earth? The simple answer is gravity. Smaller objects are pulled towards larger objects, which means that the moon is pulled towards the Earth and the Earth is pulled towards the sun. These two pulls keep the moon orbiting the Earth.
So we're trying to find what the gravitational force between the Earth and the moon is. We're given that the Earth's mass is 5.927 times 10 to the 24th kilograms. The moon's mass is 7.347 times 10 to the 22nd kilograms. The distance between the Earth and the moon is 384.4 million meters. And the gravitational constant is 6.673 times 10 to the negative 11 Newton meters squared divided by kilogram squared. So we're trying to find the force of gravity, and the equation to find that is G constant times m1, which is the Earth's mass, times m2, which is the moon's mass, all divided by the distance squared. So now I'm going to fill in my lovely little equation here. So 6.673 times 10 to the negative 11 times 5.927 times 10 to the 24th times 7.347 times 10 to the 22nd, all divided by 384,400,000 squared, which equals 1.967 times 10 to the 20th newtons in sig figs. And that's the gravitational force of the Earth and the moon.
The moon's orbit is responsible for the movement of Earth's tides. Since the Earth spins on its own axis, ocean water is kept at equal levels. However, the gravitational pull between Earth and the moon disrupts this natural balance. The phase of the moon determines the magnitude of the tide. A full moon will result in tides of a larger magnitude than tides that occur at waxing and waning crescents. In a 24-hour period, there are about 2 high tides and 2 low tides. However, this depends on where you are on Earth. When the moon is orbiting close to a body of water, the water is drawn to it, creating a bulge. This is known as low tide. The tides will come in once the gravitational pull of the moon is not acting as strongly on the water, which is known as high tide. Tidal bulges are formed on opposite sides of the planet through a combination of gravity and inertia, and stay aligned with the moon as the Earth rotates.